Hi everyone, welcome back to our channel Chamaku. So, మనం intermediate first year chemistry syllabus chapter 3 chemical bonding and molecular structure. Today we will be completing this chapter. So, from this chapter we will be getting short answer questions 2, which is 4 plus 4 8 marks, or sometimes if we check the previous papers, we got LAQ, one LAQ. So either we will be getting two short answer questions or one LAQ. So let's complete all those questions which are repeated from the previous papers and also the important questions. So first we will be completing the short answer questions, then we will be completing the LAQ, which is important. So the first one, explain the hybridization involved in PCl5 molecule. So the hybridization involved in PCl5 molecule is sp3d hybridization, intermixing of one s orbital and 3 p orbital and 1 d orbital combined to form 5 sp3d hybrid orbitals. So the bond angle of this PCl5 molecule is 120 degrees and 90 degrees. The shape of the PCl5 is bipyramidal. So this is the example of sp3d hybridization which we got as PCl5. So phosphorus, the atomic number is 15. So let's write the electronic configuration: 1s2, 2s2, 2p6, 3s2 and 3p3. Okay, so 3s2 and 3p3. So the excited, this is the ground state configuration. Now let's see the excited state configuration. So here we have 3s in s orbital of this, we have 2 electrons. So one electron will be excited to d orbital. So d orbital will have 1 electron. So here s orbital has 1 electron, p orbital has 3 electrons and d orbital has 1 electron. So total combines to sp3d hybridization. So this is the diagram of the PCl5 molecule, and these are the points. In PCl5, the central atom phosphorus involves in sp3d hybridization and forms 5 sp3d hybrid orbitals. These 5 orbitals can overlap with p orbital of 5 chlorine atoms. So this is the sp3d hybridization of PCl5. Let's solve the next question. Explain the hybridization involved in SF6 molecule. So the hybridization involved in SF6 molecule is sp3d2 hybridization, intermixing of one s orbital and 3 p orbitals and 2 d orbitals combined to form 6 sp3d2 hybrid orbitals. Okay, so the bond angle of SF6 is 90 degrees and the shape of the molecule is octahedral. So sp3d2 hybridization, one of the example is SF6. So sulfur, the atomic number is 16. This is the ground state configuration. So let's write 1s2, 2s2, 2p6, 3s2 and 3p4. The last two orbitals we will write the electronic configuration. Okay, so this is the sulfur excited state configuration. So 3s1, one of the electron from s orbital and one of the electron from the p orbital will be excited to d orbital. Okay, so the d orbital will have 2 electrons. From here 1 electron and from here 1 electron. Okay, so we have total here in s orbital we have 1 electron, p orbital 3 and d orbital 2. So this total combines to sp3d2 hybridization, and this is the diagram of the SF6, and these are the points. In SF6, the central atom sulfur, involves in sp3d2 hybridization and forms 6 sp3d2 hybrid orbitals. These 6 orbitals can overlap with p orbital of 5 fluorine atoms. Okay, so this is the sp3d2 hybridization of SF6. Let's move on to the next question. What is hydrogen bond? Explain the different types of hydrogen bonds with examples. So what is hydrogen bond? The weak electrostatic force of attraction between hydrogen atom and highly electronegative atom, fluorine, oxygen, nitrogen, of same or different molecules is known as hydrogen bond. So this is a definition of hydrogen bond. Then we have hydrogen bonds are of two types. One is intermolecular hydrogen bond and intramolecular hydrogen bond. So what is intermolecular hydrogen bond? Hydrogen bond formed between two different polar molecules is known as intermolecular hydrogen bond. Example H2O, NH3, etc. Okay. Now what is intramolecular hydrogen bond? Hydrogen bond formed within the same molecules is called as intramolecular hydrogen bond. Example orthonitrophenol and orthohydroxybenzaldehyde. Okay. So this is the bond formed between two different molecules, and this is the bond formed between within the same molecules. Inter is different and intra is within the same. Okay. Coming to the next question, write the general properties of ionic compounds. Properties of ionic compounds. In general, ionic compounds are solids. They possess high melting and boiling points. They have high melting and high boiling points. Okay. Ionic compounds are soluble in polar solvents like water, but insoluble in organic solvents like benzene, chloroform, carbon tetrachloride, etc. Any two you can write. Then ionic compounds in solid state are bad conductors of electricity due to absence of free ions. They are bad conductors of electricity because due to absence of free ions. Okay. In fused state or in their aqueous solutions, free ions are present. Then they are good conductors of electricity. Reactions between ionic compounds are very fast. They do not exhibit isomerism because ionic bond is non-directional. Okay. Moving on to the next question. Explain the formation of coordinate covalent bond with one example. So what is coordinate covalent bond? Coordinate covalent bond is a special type of covalent bond. In this, the shared pair of electrons is contributed by only one of the bonded atoms. The atom which contributes the electron pair for sharing is called donor atom. The atom which contributes the electron pair for sharing is called donor atom, while the other atom which accepts the electron pair for sharing is called acceptor atom. Which is sharing is called donor atom, which accepts the electron pair for sharing is called acceptor atom. Okay. Donor atom must contain lone pair of electrons and acceptor atom contains vacant orbital. Because donor atom must contain lone pair of electrons for sharing and acceptor should contain vacant orbital because the donor atom will be sharing the lone pair of electrons to the acceptor. So it must be vacant. The coordinate covalent bond is represented by an arrow from donor to acceptor. Example, formation of ammonia boron trifluoride. So this is the example. So guys, moving on to the next question. State Fagens's rules and give suitable examples. So as you can see, Fagens's rules are useful to predict the nature of bond formed between two atoms. So the first rule, as the cation size increases, the ionic nature of bond also increases. Example, increasing order of size of cations is, this is the increasing order of size of cations. So ionic nature order is this one. Okay. Next rule, as the ionic size decreases, the ionic nature of bond also. As the anionic size decreases, the ionic nature of bond also increases. Okay. So example, ionic nature order is this one, and it is due to the order of anion size. Okay. This is the two rules. And the third rule is, as the charge on cation or anion decreases, the ionic nature of bond increases. NaCl is ionic in nature due to less charge on Na+1 ion. AlCl3 is covalent in nature due to highly charged Al+3. The fourth rule, cations with inert gas configuration forms ionic compounds, but cations with pseudo inert gas configuration forms covalent compounds. Example, NaCl is ionic but ZnCl2 is covalent in nature. Okay, these are the Fadgen's rules, very important. So either from this chapter we will be getting 2 short answer questions or 1 long answer question. So from previous papers, if we check, we got this long answer question. What do you understand by hybridization? Explain different types of hybridizations involving s and p orbitals. So first we have to write the hybridization definition. Okay, so what is hybridization? The process of intermixing of 2 or more atomic orbitals of nearly equal energies of an atom to form same number of identical orbitals is called as hybridization. Okay, so we have types of hybridizations involving s and p orbitals are sp, sp2 and sp3 hybridizations. So sp hybridization, intermixing of one s orbital and one p orbital of an atom to give 2 sp hybrid orbitals. Each sp hybrid orbital has 50% of s character and 50% of p character. Bond angle is 180 degrees, shape is linear. So this is the example for sp hybridization, that is BeCl2. So beryllium atomic number is 4. So this is the electronic configuration 1s2, 2s2. So as we can see, in 2s2 we have 2 electrons. So one electron will, this is a ground state configuration of beryllium and this is the excited state configuration of beryllium. So from 2s2, one electron will be excited to p orbital. So we will be having here one electron and in the p also one electron. So this contributes sp hybridization. This is the diagrammatical form and this is also one molecular diagram. Coming to the sp2 hybridization, intermixing of one s orbital and 2 p orbitals of an atom to give 3 sp2 hybrid orbitals. Okay, each sp2 hybrid orbital has 33.33% of s character and 66.67% of p character. Bond angle of is 120 degrees and shape is trigonal planar. So this is the example for sp2 hybridization BeCl3. So boron atomic number is 5. This is a ground state electronic configuration. So 1s2, 2s2 and 2p1. We have 2 electrons in s orbital and 1 electron in p orbital. So this is a ground state, and if we see the excited state configuration, one electron from s orbital will be excited to p orbital. So we will be having total 2 electrons now in p orbital. So this contributes sp2 hybridization. This is the diagram and this is a molecular diagrammatic. Okay, the bond angle is 120 degrees for BeCl3. Coming to the sp3 hybridization, intermixing of one s orbital and 3 p orbitals of an atom to give 4 identical sp3 hybrid orbitals. Each sp3 hybrid orbital has 25% s character and 75% p character. Bond angle is 109 degrees 28 seconds and shape is tetrahedral. So this is the example for sp3 hybridization. We will be taking CH4, that is methane. So carbon atomic number 6 and this is a ground state configuration 1s2, 2s2 and 2p2. So one electron from s orbital will be excited to p orbital. So we will be having this is the excited state electronic configuration. We will be having 3 electrons. So this contributes sp3 hybridization. This is a diagram.